Hi everybody. Last time we were together, we solved systems of equations using word problems and just regular equations with numbers and letters. Today, we are up to 3-2, graphing linear inequalities. So it's inequalities, and you did this on the test you took earlier this week. And we're going to go through it again right now because this has two of them on here. Actually, I forgot to put the word systems here. So it's the systems of linear inequalities. So I'm going to give you two examples, and that's going to set us up for our in-class problem solving, which will be on Monday. And again, I'm really expecting everybody to have the Google form submitted to me on this before Monday's class. So I've got the two inequalities, one in green and one in orange here. And they're both set up in slope-intercept form. So the first thing that you're going to do is to graph each linear inequality. And with slope-intercept, it's pretty easy, right? -4, there's our y-intercept. And what's our slope? Up 2 over 1. Up 2 over 1. And this is greater than, so it's going to be dotted. Then we have to shade one of the sides. Which side is it that fits this? And we do our substitution with 0, our test point. So we substitute 0 in for x and y. So 0 is greater than 0 minus 4. Is 0 greater than -4? Yeah, it is. So that means everything there is shaded. And on the graph paper that you have, you will actually shade it like that. Okay? So that's the first one. Then we have the second one. Y is less than -1/2x plus 3. Okay? There's our y-intercept. Oh, the slope is negative. Down 1 over 1. Down 1 over 1. And it's going to be another dotted line because it is less than, not less than, or equal to. So there's that line. And then we have to decide where 0, which side we're going to shade to see if 0, 0 fits that. So 0 is less than 0 plus 3, because 0 times -1/2 is 0. So is 0 less than 3? Yeah, it is. So that means it's everything down here. So let's think about this a little bit. We have two lines that cross. That means we have 4 sort of areas. Because when we have two things crossing like that, we've got 4 areas. One is just green, one is just orange, one is nothing, nothing's shaded there. But this area is shaded twice by both green and orange. So our solution set, everybody, is this area that is double shaded. And with your pencil, you can really kind of shade that a lot deeper. And the meaning of that is this. Any point that is in this double shaded area makes both of these things true. Pick a point. Pick this point. -5, 0. If you put -5, 0 into both of these, they would be true. Unlike last class where our answer was a singular point that the two lines crossed, this is a little bit different. It's the area. And you need to be able to do this to then get to the next section we do, 3.3, which is going to be new, linear programming. This should be a review from Algebra 1. And I think you did this, because I think Joe mentioned in class once about the double shading areas. Okay? So, That's when it's in slope-intercept form. Let's look at one that has standard form. So here's one that has standard form. And remember what we do. I'm hoping you're getting used to this now. Where are the intercepts? X is 0. So put 0 in because 0 times 6 is 0. Negative 2y and 12. So that means this is going to be negative 6. Substitute in 0 for y. 6x equal to 12 there. That's a 2. So 0, negative 6. And then 2, 0. And it's greater than or equal to, so it's a solid line that will look like that. Which side do we shade? Well, substitute 0, 0 in for this. 0 minus 0 is 0. Is 0 greater than 12? No. So that means we're shading this side. Okay? Standard form for the second one. X is 0. So 0 goes there. 4y is equal to 12. Y will be 3. 0 for x. Sorry, 0 for y. 3x is 12 and 4. So 4 goes there. Before I graph it, I will mention, I chose really easy numbers for this. They may not always be this easy when you're doing them. I did it for the sake of teaching that they're easy. They might be a little bit more difficult. So 0, 3 is right there. 4, 0 is right here. There's this line, and it should be dotted because it's greater than, not greater than or equal to. Okay, which side do we shade? Substitute 0, 0, our test point. 0 plus 0. Is 0 greater than 12? No. So that means here's 0, 0. It's not going to be this side. It's going to be over here. And where is our double-sided area? Take your pencil and shade double sides in right there. Okay, and anything within that double shaded region is what makes both of these true. Pick a point. 10, 3. Substitute 10 in for x, 3 in for y. 10 times 3 is 30, plus 4 times 3 is 12. 30 plus 12, yeah, that's greater than 12. And it would fit in here too. 6 times 10 is 60, minus 2 times 3 is 6. That is greater than 12 as well. And so that's why it fits in there. Okay, so I can't stress enough, you guys, the ability to be able to take either standard form or slope-intercept form and graph the inequality and shade. Because this section kind of leads us to 3-3, which is going to be an important one with linear programming. Okay, so I'm done here, done a little bit early. I think this is only about an 8-minute video. So submit the Google form to me before class on Monday, and then we'll be working on problems like this in class. All right, have a good weekend.